Hey everybody, how's everybody doing out there? Time for another wander. Hey, before we get started, I just want to do one thing. I want to quickly recognize the fact that while we're talking about this land at Warren Wilson College and we're looking at landscape features, we're talking about different management and species, I just want to recognize the fact that we're not the first ones to be on this land. This land has been used for centuries by indigenous folks who knew probably more about this land than we do. And I think it's really important to respect that and understand that we're not the first ones to think about these issues on the land and these species, and we sure as heck won't be the last ones. And I just want to make sure that's recognized before we start. So we're going to head out today, and if you looked at last week's wander, we looked at a basic cove forest, a mesic basic cove forest, north-facing cove, lots of moisture, great soils. We thought we'd go to an opposite extreme today and head up to a dry upland site, which is going to have a completely different species mixture and different structure up here. So let's talk a little bit about that first before we go in. So when you think about forests in this area, a lot of what dictates the vegetation you're going to see is light, as we've talked about in past wanders, but also moisture. How much moisture is there at the site? And I'm not talking about drought years versus wet years. I'm just talking within a year, how is the moisture regime across the site going to be dictated? And a lot of that has to do with topography. So we are at an upland slope position. And when you think about it, there's two ways to look at topography in relationship to what plants you find. The first one is elevation gradients and forest types. So when you think about elevation gradients, you think about going from Asheville up to Mount Mitchell. And when you do that, you're passing an elevation gradient and you get three forest types. You get oak hickory forest, where we are now in Asheville. You go up into northern hardwood forests when you get up around Craggy, and then you get up into spruce fir forest when you get up to Mount Mitchell. So those are forest types, broad forest types that are fleshed out, dictated by elevation, right? But within each one of those elevations, right, within each one of those forest types, you have slope positions. You have an undulating landscape with slopes and valleys, slopes and toes. And when you look at those, you can have these dry sites that are up at the top of a slope, and then you might just go down 200 feet. It's not an elevation gradient, 200 feet to the toe of that slope, and it's going to be much moister. So you're going to have a dry area at the top, you're going to have a mesic or middle moisture at the middle, and you're going to have a wetter area at the bottom. And the species will pan out along that gradient. So when you think of elevation, you think of broad forest types. What is the forest type at different elevations? But then when you think of slope position, you think how are the species within that forest type going to be laid out across the landscape, quite often due to moisture regimes. So what we're at here is an upland slope position. So we're at the top of a slope, and it's going to be very dry, and that's going to dictate the different species we're going to see. So let's wander. Let's go in and talk about some different species. So this is a great species here. We've talked a lot about white pine. If Pete wants to pan over, we're on the edge of a white pine plantation. So we've talked a ton about white pine. And if you remember, there are four main pines here in this, on Warren Wilson campus and in this region. I'll give you a second to remember. Do you remember what those four pines are? Come on, you got to get at least two of them. All right. White pine, Virginia pine, pitch pine, and shortleaf pine are the four major pines. Like I said, there's Table Mountain pines, there's some other pines in the area, but those are the major pines in this area. And what you have right here is a pitch pine. This is a pitch pine. This is a three-needle pine. So if you remember, the white pine has 5 needles. That's a 5-needle pine. The pitch pine is 3 needles. The Virginia pine is 2 needles. And the shortleaf pine is the one that messes up the whole system because it's 2 or 3 needles. But this is a pitch pine here. And pitch pine's a beautiful tree, really common in New Jersey. If you think of the Pine Barrens, pitch pine is one of the most common trees in the Pine Barrens up there. But if you think about this tree, when we looked at white pine, you might notice the difference is white pine grows straight and true. Pitch pine generally does not grow straight and true. If you look at this form, you don't have to be a forester to see that you're not going to get a lot of boards out of this tree, right? This is not a straight trunk that's nice and even that you can make boards out of. It's a beautiful tree. It's the one way to identify this one compared to shortleaf, which is what you'll confuse it with, is the fissures between the scales on the bark are really deep and you can actually stick your fingers in them. Shortleaf pine is going to have these scales. They're going to be more even and square, and the fissures between them won't be as deep. One of the really cool things about pitch pine is, you know, many of you out there know that if you cut a red maple and leave the stump, it'll sprout. Stump sprouts come up. Pines don't do that in general. Most gymnosperms do not do that. They do not sprout. Once you cut a white pine, it's not going to re-sprout. Although pitch pine is one of the pines that actually can re-sprout. And sometimes you'll see a pitch pine, you'll come to a pine and there will be all these needles pointing out on the trunk. And when you see that, you know it's a pitch pine because it's the only one of our pines that will actually be able to send out needles from the trunk. So that's pitch pine. Great tree. And the pine cones, the cones on it are these short ones, unlike the white pine, which are long. These are short and they have little tiny spines on each one of the scales. So that's pitch pine. So I wanted to point out this species, and a lot of you might be looking at it and just think it's sugar maple, right? This is actually not sugar maple. This is Norway maple. This is an exotic invasive maple species that we have. Many of you who might be living in the suburbs or drive around in neighborhoods might see what they call the king crimson maple. It's that maple that's got the bright purple and red leaves on it year round. That's a cultivar of this species. It looks an awful lot like the sugar maple because it's got the 5 lobes, right? And it's kind of straight right here. But if you break off a leaf and you look where the petiole is connected to the branch, the petiole of the leaf is the appendage that connects the leaf to the branch, and squeeze it, you'll notice a milky white latex comes out. It looks like milk coming out of the stem. That is a great indication that it's a Norway maple and not a sugar maple. If that sap was clear, it would be a sugar maple. One of the things I worry about with the Norway maple is incredibly shade tolerant, right? And from some of our past wanders, you might remember that I said that most of our invasive species like high energy, high light, high disturbed sites. So when you get into a forest interior where it's shaded, cool, low energy, generally speaking, there's not a lot of invasive species. This one though, because it's shade tolerant, is one I worry about because it could creep into interior forests and become a problem. If we start having shade tolerant invasive species, it's going to be really hard to find intact interior forest that's not full of exotics. I've actually seen, it's not as much of a problem here, but where I'm from up north, Connecticut, New England, New York, I've actually seen this species as a monoculture underneath oak stands. And one of the issues are, if that oak stand ever comes down, this would fill that site, and the only thing that will regenerate underneath the Norway maple is more Norway maple. So you could have this perpetuating cycle of this exotic species getting in and holding onto the site. So it's one that I worry about a little bit. Again, it's called Norway maple, looks just like sugar maple. The difference is the sap that will come out is milky white instead of clear. Here you can compare the red maple leaf to the Norway maple leaf. The Norway maple leaf has these larger teeth and 5-lobed, and the red maple has a bunch of teeth on it, it's only 3-lobed. So this is red maple. I don't think I've talked about red maple yet. Red maple is an interesting species. We say that red maple has a wide ecological amplitude. And what I mean by that is red maple will grow on shady sites, sunny sites, dry sites, wet sites, It'll grow in nutrient-poor sites, nutrient-rich sites, disturbed sites, intact sites. It grows just about anywhere it wants to, and in fact, it's the most common tree right now in the continental United States. So there's a paper written a while back in the 90s called The Paradox of Red Maple. Why is red maple so common in our forests? But it wasn't really common years ago, a couple centuries ago. Pollen records show it wasn't anywhere near as common as it is now. And one of the theories that I prescribe to, there's different theories, but one of the theories is red maple does not like fire. It's got really thin bark and it can't tolerate fire. Another name for red maple up in New England is swamp maple, right? So what one of the hypotheses is that red maple was really relegated to swampy areas, wet areas, where fire wouldn't burn into. It wasn't able to come out of those wet areas when natural fire regimes were happening because it'd be knocked back. But because we've suppressed fire in the United States, the red maple is able to come out of those wetland areas and take over much more habitat than it would have with the fire. Right? So it's not, you know, some people think, oh, it's tied to swamps. It's not tied to swamps, only it's tied to swamps because there would be no fire in that area, which is kind of an interesting way to look at it, right? With fire suppression, we've probably allowed red maple to spread out into more sites. So this is red maple. It has this grayish bark, and the leaves are a little bit different than the Norway maple. So here are a couple oaks I want to point out. This here is our northern red oak, and this here is a black oak. And you might notice a couple different features on them. You might notice that this northern red oak on my right, your left, right, has pointier lobes than this black oak here, which is kind of rounded. Another thing you'll notice about the black oak, you won't be able to pick it up now, but black oak is Quercus velutina, velvet-like. And if you rub the back of a black oak leaf, you'll notice that there's these hairs that come off. Whereas the back of a northern red oak leaf is shiny and smooth, the back of a black oak leaf has these hairs on them, right? The black oak is really a dry site oak. This is an oak that grows on dry upland sites. It's part of the red oak family. So another thing you'll notice about both of these is this one and this one both have these little points at the end of each lobe. And so you can tell the red oaks from the white oaks. So there's 5 oaks in this area. There's the white oaks, which are the true white oak, the post oak, and the chestnut oak. They will all have rounded lobes without this little spine on them. And then you have the red oak group, which is the scarlet oak, the black oak, the shingle oak, the northern red oak, and the southern red oak, which will all have these points on the teeth. So this is black oak is a dry site upland oak. It doesn't really make a good timber tree. It doesn't grow true and straight. So there's not a lot of high quality black oak timber out there. Now the northern red oak, this oak here, this is one of our most important East Coast oak trees for timber. The northern red oak grows straight and true, and actually it's a great mesic oak. It grows not on the dry upland areas, I mean it's here, but the great timber trees are on these mesic sites. So on the dry sites, it's a little too dry for some of the trees. They don't grow in great shape. In the lower slopes, it's a little wet, but in that Goldilocks, that middle slope site is where the moisture is just right, and it's where we get a lot of our high quality northern red oaks. One of the most difficult and one of the most challenging silviculture, if you're thinking about timber, issues in the southern Appalachians is trying to get northern red oak to grow and compete on these good timber sites, these mesic sites, with tulip poplar, because tulip poplar generally wins on those sites. So you can grow oak up on these dry sites pretty well, but you don't get the good quality timber on these dry sites. It's on these middle sites where you get the good quality timber, but that's also where you have the highest competition from tulip poplar. So northern red oak, black oak, two different oaks. I should also point out, and I'm not sure if I talked about this before, the white oak group, those 3 white oaks, have far less tannins in their barks, far less tannins in their wood, and far less tannins in their nuts, whereas the red oaks have high tannin levels. And tannins are a bitter chemical, and it's kind of interesting. The white oak group acorns are only on the tree for 1 year, whereas the red oak acorns are on the tree for 2 years. And one of the evolutionary hypotheses is that the red oaks would put on more tannins in their nuts because they're out there for predators for longer to inhibit the eating of them, while the white oaks aren't out there for as long, so they didn't need to put on the tannins. And again, if you're trying to make oak flour, you would want to use white oak, not red oak. Another thing you'll notice if you look at the structure out here, on these dry sites, dry upland sites, you're going to get less dense trees because there's less moisture. So you're not going to get as thick of forest structure as you would on some of these mesic or bottomland sites at the bottoms of valleys. Here's a great example of a scarlet oak. So scarlet oak, you won't be able to see the leaves up top, but scarlet oaks are another red oak. But if you notice, compared to the red oak, the scarlet oaks have these real deep sinuses. These are the lobes, these are the sinuses in the middle, and you can see how deeply lobed the sinuses are on this one. How the lobes come out and the sinuses are very deep up against the middle. So this is a scarlet oak, another dry side oak. And another thing you'll notice about scarlet oak quite often is it gets what we call butt swell. Scarlet oak, the butts of the trees swell. There's another one if Pete wants to spin around and look at that one. That one's really got butt swell on it. And what we like to say, and I just like to say this, so I'm going to point it out, butt swell often leads to butt rot. And when you get the butt swell on the tree, you get butt rot, you get funguses coming in, and they'll actually come up the tree and they can render the tree not valuable for timber. Again, we talk about values. Please hear me. When I say not valuable for timber, that doesn't mean it's not valuable, right? A tree has many other functions and values besides just timber. But quite often on these scarlet oaks, when they get big butt swells on them, they're no longer useful for timber. Hey, does anybody remember what this one is? You got this one? Now remember, it's gray. That's another Oriental bittersweet. All right, let's walk on a bit. You know, we talked a lot about, on one of our past wanders, we talked an awful lot about snags, about dead standing trees and how important they are for wildlife. So here is another great example of a forest resource. This is what we would call coarse woody debris, CWD, coarse woody debris. Dead logs, dead branches down on the ground. These are really important for a few reasons. One is habitat, right? These are great habitat. They can have little areas underneath them that salamanders can get into. When they still have branches and they're raised up a little bit, they can have areas for small critters and mammals to get under. But another really important use for these is our carbon sink, sorry. So a lot of this wood that lies on the ground is sequestering carbon. Just like the tree is sequestering carbon. Well, this is a pile of carbon here too. And as it decomposes, it releases that carbon into the atmosphere and becomes a carbon source. One of the things, one of our Warren Wilson students did a large project up and down the East Coast looking at how long this coarse woody debris lasts in the forest, right? And you could think that the longer that this wood stays in the forest, this carbon is locked up and not in the atmosphere. Well, what she found was as temperatures warm, the decomposition process speeds up, And this coarse woody debris is decomposing quicker than it had decades ago and releasing the carbon into the atmosphere. So coarse woody debris on the ground, it's not just dead wood, it's important for all kinds of reasons. It's not a big nutrient source because it's mostly carbon, there's not a lot of nitrogen in it, but it's mostly just a carbon store. Here's a Virginia pine. I don't think we've talked about Virginia pine. There's a bunch of Virginia pine in here. Virginia pine is not a very valuable timber tree. If you'll notice the dead branches all along it, you notice the dead branches all along those there. This is also a tree, when you rub it, it flakes off. The bark flakes off. And it's got this orangey kind of cinnamon colored bark to it. Virginia pine is a fast growing, mostly shade intolerant pine that comes in quickly after land is abandoned. You abandon farmland in the north, New England, you get white pine. You abandon agricultural land here in the south where there's pine around, you're going to get Virginia pine. But because Virginia pine doesn't self-prune well, it doesn't lose its lower branches, it doesn't make a very valuable timber tree. It's very knotty. Any of you who are familiar with the log cabin on campus, the log cabin about 4 years ago was rehabilitated. Some of the logs were starting to fall apart, and we did use some Virginia pine for that. But you don't really make boards out of Virginia pine. This is a post oak. This one here is a post oak. This is another white oak. And as you look up into the canopy, and if you get it against the blue sky, you can see that the leaves come out almost like a cross. They come up and they have one upper lobe, and then they have two side lobes that come out. Almost like a cross. Quercus stellata. It's not really well represented in our forest. There's some, but it's a beautiful tree, and again, it's a great wildlife tree because it's a white oak, so the acorns are very desired by turkey, deer, bear, that type of thing. So that's another one of the white oaks, Quercus stellata. All right. Here's another oak. This is another one of the red oaks. This is southern red oak. Southern red oak has this rounded base, right? And it's got the three lobes up top. Some people say it looks like a turkey foot. If you go down and you clip off the bottom and you just look at the bottom, it looks like a bell. Some students have told me they remember it because they remember the phrase southern bell, southern red oak. It's got a bell shape when you look at it. Sometimes this middle lobe is very long, and one student pointed out to me once that the way that he remembered it was because it had this long middle lobe. He said it's the only oak that gives the professor the middle finger when they're holding it up. So I kind of like that one. But this is another one that's kind of pubescent. It's kind of fuzzy, right? It's got these three lobes, but you'll notice it's got the little point on the tip, and that point on the tip identifies it as a red oak. So this is southern red oak. It also looks like a turkey foot, right? It looks like a turkey foot. So that's southern red oak. Here's another pitch pine. And this is great. You could see it on this one. You could see needles coming out of the bole of the tree, out of the stem of the tree. You would not get that on a white pine. You would not get that on a Virginia pine or shortleaf pine. But you get these live needles coming out of the tree. You'll see that on hardwoods, not on softwoods. I just used a term that's been thrown around and it causes a lot of confusion. Hardwood versus softwood is an old forester's term. It has absolutely nothing to do with how hard the wood is. When someone says there's a bunch of softwoods out there, what they mean is there's a bunch of pines, there's a bunch of conifers, spruces, firs, gymnosperms are softwoods. And when you say hardwoods, you're talking angiosperms, broadleaf trees, oaks, maples, dogwoods, that type of thing. But there are plenty of softwoods that have harder wood than some hardwoods. So it's a confusing term that really is a forestry term. So softwoods, gymnosperms, conifers, hardwoods, angiosperms, broadleaf trees. Oh, this is great. So happy we decided to walk this part because we're getting the oaks. Here's another oak. This one really confuses people. They sometimes think it's a rhododendron or they think it's a mountain laurel, because this one here is our only unlobed oak up here in the mountain. Okay? What I mean by that is all the other oaks we've looked at have lobes, right? This one here is a single, simple leaf without any lobes, right? There are other unlobed oaks like willow oak out on the Piedmont, live oaks out on the coast, but up here in the mountains, this is the only one. It is a red oak because it has the point at the tip, but this is shingle oak. This is shingle oak, and it's an unlobed oak of the mountains. It is not a rhododendron, it is not a mountain laurel. One of the ways you could tell the oaks, it's tough right now, if you're ever looking at it and you're trying to figure out what it is, it's tough right now because the buds aren't present. But if you look at the tip of a tree, the tip of a branch, and you're trying to decide what it is, and you see a whole bunch of little buds at the tip, what I call the stegosaurus tail, it looks like an old stegosaurus tail, that is an oak. What we say is the oaks have all their terminal buds clustered at the twig tip. So if you were to look at this and try and figure out whether it was a rhododendron or an oak and it had buds, you go all the way out to the tip, look at it, and if there's a whole bunch of buds all stuck at the tip, that would be an oak. If there was just a single bud, it would be a mountain laurel or a rhododendron. Here's a good one. So we have 3 main hickories here in the mountains. Again, I want to be careful when I say main, ones that are very well represented. So this one here is mockernut hickory. Mockernut hickory, Caryatomentosa. And one of the easy ways to tell your mockernut hickory is if you look at the backs of the leaves and you look at the young branches and the petioles, they're really, really fuzzy. Tomentose is Latin for hairy, one of the words for hairiness. So if you look at this one, you can see that there's, when you have the hickory, they have these compound leaves. So I want to be careful here. I'll pull off a leaf. This is a red maple leaf. This is a simple leaf. A simple leaf only has one blade, right? One blade. This is a compound leaf. This is a single leaf with 7 leaflets. 1, 2, 3, 4, 5, 6, 7. So this isn't a leaf. This is a leaflet. This whole thing is a leaf, right? A simple leaf, a compound leaf. And so when you look at this leaf, you'll notice that it's very fuzzy, very hairy. That is in comparison to one of these brambles. Not today, I don't know if I see one up here. You'll notice that there's some that are very, very shiny. That's our pignut hickory, glabrous. And that's Latin glabros is skin-like, without hair. So this is our mockernut hickory. Great tree. We have 3 main hickories up here. Mockernut, bitternut, and pignut are the 3 main ones. We do have some shagbark hickory up here in the mountains, but it's not really well represented. And on one of these rambles, we'll make sure we get all 3 hickories. Hickory is a great wildlife food when you think of hard mast. So when you think about mast can be a few different things. A masting event is when you get a lot of acorns come out, you get a lot of seeds come out, so it can be a masting event. Mast can also be used as a noun. Mast is the nut or the fruit of the tree. And we think of mast in 2 different ways. We think of soft mast and we think of hard mast. Soft mast are berries and hard mast are nuts. So this is a hard masting tree that makes hickory nuts. And it's going to be really important to preserve a lot of these hard masting trees, because when you think about the major hard masting trees in the eastern US, it would have been chestnut, which we know that there's no more American chestnuts producing fruit. There's plenty of American chestnut, but they're not producing fruit. So we'd have chestnut, we'd have oak, we'd have hickory, and we'd have beech, would be the important, there's others, you know, hazel, there's some other important ones, but those are the 4 major ones. Well, we lost the chestnut. Beech isn't really well represented at this elevation, so hickory and oaks are really important now to manage for their hard mass for wildlife. Let's try and get one more species and wrap this one up. Oh, here's another great one. Those of you who watched our last ramble, here's a test, here's a quiz. Is this false Solomon seal or true Solomon seal? I'll give you a hint. The flowers are coming up underneath this plant, underneath this leaf, rather than at the end of it. So which is it? False Solomon seal or true Solomon seal? Ding,
True.
ding, 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 ding. What's Pete say?
True.
Pete says true. Pete's the winner. True Solomon seal. Because again, remember, the flowers and the seeds and berries are coming out underneath rather than false Solomon seal where they come out at the end. So I think we're going to wrap it up for today. We saw a bunch of oaks. What do you want to take home from this? Again, site is really important. We're on a dry site here. Again, elevation, one way to think about it, elevation, broad elevation gains are what dictate forest types. When you think about elevation, you think of broad forest types. Again, for us, it's oak hickory here in Asheville, northern hardwoods up around Craggy, and then spruce fir up at Mount Mitchell. So that's elevation. Slope position, whether you're at the top of a ridge or at the toe of a ridge, dictates where the species within that forest type are going to be found. So that's one of the important things to take home. And the other important thing to take home is oaks. Oaks can be lumped into red oaks versus white oaks. White oaks are far more important for wildlife, and then some of the red oaks are more important for timber. And the last thing I want you all to take home is just keep in mind, we're not the first ones here. We won't be the last ones here. Any information I'm giving you is not information that I've come up with my own little pea brain. It's built on generations and centuries of information that's come to us from other folks, and we need to respect that. Take care until next time we take a walk.